Okay, this is the Half-Life Lab for Nuclear Physics. As you can see, this is about 200 M&Ms right here, and you can't really see where the M's are. There, you can see it. But I already counted this big pile, and there are 110 which are not decayed, so the M's are up, and then there are 90 that are facing downward, so they are decayed. So this demonstrates a half-life because over time, part of the molecule, which I guess would be all these M&Ms, emits out certain particles and then decays. And that would be the decayed M&Ms would be the particles emitted out. So next we're just going to do this again. And so I'm going to take all the decayed ones out. So the ones with the, well, I guess I'm going to take all the ones with the M's up. So all the ones that were non-decayed out. And then shake them up and do it again. So it's just going to take a second. There's all the ones on one side. So just going to throw those back in there. Alright. And then all the ones on this side are decayed, so that's about 90 on that side, and 110 were not decayed. So I'm going to mix those around, so these are already done. So I just take over here, mix these around, and pour it out again, and then recount. So that's going to take just a second. Okay, so counting from here, it looks like about, just on this side, it looks like about 60, I've counted, rounding a little bit, 60 are non-decayed, meaning that the M on the M&M is up, and then 50 decayed. So again, that shows a half-life. This big molecule of all these M&Ms is slowly decreasing over time by emitting these other particles, which are all the decayed ones, and then that creates a new element, or this smaller blob of M&Ms, and so it will continue in this fashion again if you want me to put all these back in and do it again, and essentially around half of the element would decrease over this time, and so that shows a half-life. Some elements have very long half-lives. Obviously this M&M molecule does not. Again, the same thing. You just count out how many, and it would be about half, just because of the pure chance, are up and about half are down. And so here, it looks about like 25 are non-decayed with the M's up, and about 35 are decayed with the M's down. And so you could keep doing this. It's basically the same thing. It's just going to be a lot of counting, but this just shows half-lives because it shows how over time radioactive isotope will decay, and then it would become a new element with less. And if these were considered nucleoids, protons or neutrons, this amount lessens over time through alpha or beta decay. And that's how that works. Also, I went ahead and I wrote down the numbers for this for the first 4 rounds. I did a couple more before this, just to have the numbers. But you can see you can calculate percent activity by placing the amount non-decayed over the total amount, and then you can get that. So and you see percent activity decreases, and that just shows half-lives because there's less to decrease over time as the molecule continues to degenerate. And so that's the half-life lab. This would continue probably for about 10 or so half-lives. It's not necessary for me to keep counting all these, but you get the point. Thank you.